That was kind of you to say. I hope I can live up to your expectations today. Um, so if anybody that's in the group here could just quickly put in the chat, I'd like to know who we're talking to, just so we know, just like she asked. Oh, first of all, good morning, everyone. 8 o'clock in the morning, and we're all getting to this on a Thursday. Isn't this fantastic? Right? It's better than going and having ham and eggs on the way to work. So my name is Larry Waters. I don't know if anybody's seen any of my webinars or anything on here before. It's okay if you haven't. I completely understand. Uh, Today we're going to be talking about heat pump water heaters. We're very focused on that, but a little bit about who I am, just so I can hopefully earn a tiny bit of credibility and say, who is this dude? So I've been in the HVAC industry since 1981. Well, I went to school in 81, got out in 82, so really 82. Back when we were using duct tape for duct work and all the drills had cords on them. So I remember when the first cordless drill came out during my career, and I was like so excited about it. I'm a NATE certified HVAC technician. I have been for 24 years, and I've kept that going all these years. And then also a BPI certified, Building Performance Institute certified kind of. I have a really tight focus on building science stuff. And a lot of people went and got a BPI and kind of just went back to the status quo. I like to say that the classes I went to, they had the Kool-Aid to sugar mixture just perfect, so I drank a lot of it. And once I understood how houses worked, I never went back to putting in things that weren't right for the house. So in 2015, that led us to putting in heat pumps only at the company I was at before I started this company. Very good people, love them to death, still good friends. But he would have liked for me to sell a furnace once in a while, and I just wasn't doing it. So in 2020, I saw what was kind of coming down the pike with electrification in California. I was tuned into a couple of different boards and advisory positions, and I just said somebody's got to do this. So at 55 years old, I took a plunge and started this business, which is it's one way to do it. But if I had started it before this, I wouldn't be on this path. So that's who I am. If you haven't caught any of these before, we'll probably do a rerun on some of these, maybe next season. There's a lot of good content in here. We're going to talk about today, though, the subject du jour is application-specific heat pump heater design, or what we call more than one brand in the hand. If anybody out there has installed a heat pump water heater before, can you just pop that into the chat? Just say installed one, or looking to install one, or wherever you're at on that, and we can help kind of tune the information to you. And then join us next month on the 28th. This has been a good one. We've given this webinar to a couple of different resources, and it's always a good one. Minimizing callbacks on heat pump projects. Now, I don't just get on these things to talk to you about stuff and read a book the night before and try to translate it or anything like that. Everything that is going to come to you now is all from our lab, which is our business, and we just share what's going on in the business, the hard and the easy and the good and the bad, and we try to help other contractors kind of not have to deal with some of the rough stuff. So that's a lot of the minimizing callback. So we'll see you then on the 28th of next month, hopefully. Okay. So I always share my mission statement on all of these calls because it's important to know. And if you guys are in business and you don't have a mission statement, values, and vision, you should do that. It brings the whole team together. You know what you're focused on. But ours is to provide the most efficient, cost-effective electrification solutions. To California homeowners. It used to say and ratepayers in there, but I've heard that's a bad word in the circles. To practice good stewardship of the electrical panel, which means the majority of the houses that we fully electrify, we don't put a new panel in. We do it on their existing infrastructure. And then train and influence other contractors to do the same. And that's what we're doing today. So right in our mission there. So what's the agenda for today? Is the emergence of heat pump water heaters. Why the heck would anybody want one of these really expensive things, right? We're going to talk to some considerations to inform system selection and some scenarios and real world case studies. So without further ado, There is a disclaimer, and I know everybody has a disclaimer in life, right? But the water heater brands and the models featured in this presentation are provided solely for educational and illustrative purposes. We use several different brands of this equipment. Like we sell 5 different brands of heat pump water heaters, so I'm not necessarily into one more than the other. It's just application specificity. So I do not endorse or recommend any specific manufacturer over another. Every product has its strength and ideal applications, and that's why we choose multiple type, is for the successful performance of the system and the ideal application. Additionally, all design and installation guidance provided here is general in nature. Always consult the latest manufacturer installation manuals and technical documentation to ensure compliance with code, safety standards, and warranty requirements. Now that that's been said, let's get going. All right. So what's the backdrop for this? Why the heck are we even doing this? This sounds kind of crazy, right? So, um, why are people wanting heat pump water heaters? They're more expensive, they're electric, I gotta run a wire. A lot of plumbers out there just telling people, oh, you don't want that, right? So we're gonna hopefully get into that a little bit today, and you have a better understanding of why, and give you some talking points with your customers. So why all the heat pump water heater hype? Okay, if you want to put something in the chat of why you think that is, but why all the hype, right? It, a lot of it is because water heating is 18% of the average customers or consumers electrical or energy use profile. Okay, so a lot of houses, like I go down to Oxnard every once in a while. We stay in a VRBO. It has a heater. Every time I've been there, I've never turned it on. So obviously they don't have air conditioning there. So in a situation like that, the water heating is even a bigger portion percentage wise of the utility costs. So if we can reduce those utility costs and kind of make the world a little better, then why not do it, right? Okay. So why are we doing this? Is it climate change? It could be. Is it health? Is it air quality? Well, it really comes down to most of the regulations in the state that are ruling over kind of gas usage are clean air regulations, right? The CARB board, the South Coast Air Quality Management District, up here where we are, the Bay Area Air Quality Management District. I think they changed their name or something, but they're always going to be known as that to me. Um, One of the reasons is like we are proud owners of a lot of things in California. We got Yosemite, the Golden Gate Bridge, the beautiful California coastline, homeless people, and also we have a ton of, or we have 8 of the most polluted cities in the country still. So there's all kinds of air quality problems. So every water heater that runs out there, every time it comes on, every gas model is going to have emissions that come out of it, right? If we can reduce those emissions and take the emissions back to the point where the electricity is generated, then there's going to be an overall reduction in our cities of emissions. Same thing for furnaces, right? It's really, really important that we get this down, and heat pump water heaters just happen to be a really good way to do it. So looking at a little bit of history around that, this has been going on for a long time. When we do these classes out in the world, it seems like every other class I get like the skeptic, right? And they say, "Oh, it's just that crazy dude up in Sacramento." And you know what? And part of it is, but this has been going on for a long time. So I'm not gonna definitely not gonna take the side that says Sacramento isn't crazy. But we've been doing this for a long time. The first Clean Air Act goes all the way back to 1963. The CARB board was founded in 68. Some of these initiatives were signed in by Republican governors, so it's in all of our best interest to make sure we have clean air to breathe and clean water to drink, right? So this needs not to be the political football that it has become. So a couple of the big ones is SB 1477, the technology and equipment for clean heating. You might know that as Tech Clean California. That really came in around 2018. They were bringing it in between 2016 and 2017. It almost didn't come to fruition. There was a couple of naysayers in the vote that we had to get a lot of opinion from the field to say, no, this is a good thing to do. It's going to get that over the edge. So that passed in 2018. And the things don't always go real fast in the government. So it really was 2019, end of 2019, early 2020, that you might remember was the 2 weeks to stop the spread that ended up to 2 years before people come back to work. And so that put a delay on everything. We had zero emission vehicle mandate. I think that's probably done now. The governor directs the CARB in 2022 to adopt the 6 million heat pump goal by 2030, and then the CARB implementation to phase out gas-fired water heaters and furnaces by 2030. And then, of course, the Bay Area had to one-up them and say, hold my beer. And they said water heaters by 2027, furnaces by 2029. So there is this thing going on, and that's driving some of the marketplace of this. So what can we do about it? Well, in order to reduce emissions over the entire grid and bring what we need to do it, they have to build up the grid, right? There's a lot of things happening with the grid behind the scenes. There's money being spent on hardening it and making it to where it's going to deliver more energy. And the electric companies are on this right now. So we don't have to worry about the grid. Some of your customers are going to ask about that. But what can we do to move this forward? So a very popular pathway is to electrify our power, remove as much of the gas power infrastructure and just use it for peak loads or peak shaving or whatever we're going to use it for, but electrify as much of it, give us as much renewable energy as we can so that we don't have to use the gas power plants as much. And then we need to electrify our houses, right? We need to change those gas appliances from gas to electric, which is, if anybody's going, why would you want to do that? You know, if you have your flip phone, please hold it up to the camera, right? So a technological change in the industry and the idea that we have such great technology for our homes now that's electric and clean is helping us move that way. But what we have to do is when we're helping our customers make a decision on moving away from gas, we have to make sure that they're electrifying efficiently. So we need to focus on energy efficiency, and putting a heat pump water heater in the wrong place or making it to where it doesn't achieve what it's designed for is not what we call good electrification, and it's not electrifying efficiently. So that's what this whole course is about. Okay. So this is pretty interesting. Like in 2024, solar energy was catching up with gas. Like our gas dependency has gone down as our solar capture ability has gone up. So we're at this point where a lot of our power is created by renewables at this point. So we're doing really well, and we're reducing our need for those gas plants, and we're definitely reducing our need for gas in the house. So 93% of the days this year through June were already powered by 100% clean energy for at least part of the day. And if you guys haven't seen this thing, I would suggest maybe going and looking at it. This thing called the duct curve. I don't think that's part of our thing today. It's not. The duct curve. We put a lot of energy on the grid during the day when the sun is out, just at the time when we're using less of it because everybody leaves home. And right as the solar shuts off at the end of the day, everybody gets home and turns on all their stuff. So we have these intense ramps in our new kind of energy pattern. But what we've been able to do is round those out with this renewable energy. So far, as of June 30th, we've gone 168 days. That's just incredible. Just a few years ago, there was an article that came out in the LA Times, and it said we had a momentous occasion. California met 95% of their energy for a period of time with solar and renewables. And if you read further into the article, it was like 4 seconds, and it wasn't quite all of the state. So now, just a few years later, we're already a large part of our day every day is completely provided through clean energy sources. So it's a really exciting time. So why does that matter in the grand scheme of heat pump water heater stuff? Here's the curve, right? So the California main grid electricity demand, wind and solar of July 26th of 25. And this line here is our demand curve. And this yellow here is our solar. We got a little wind in here. We got some geothermal, got some large hydro. And over here, you see like we're charging batteries in the morning. And then in the afternoon, we're charging batteries with the sun that are going on. Lots more solar systems now have batteries connected to them, whether they're big commercial solar plants or just rooftop residential or commercial. More and more batteries are getting installed, and that's helping us kind of ease the curve at the end of the day. But we have this. This is really what's going on. 6:15 in the morning, we start producing solar energy. It produces really well till about 5:30 in the evening on the summer days. So we got a lot of power there. And in fact, it's more than we actually need. So down here is Saturday, July 26, 2025 with wind, water, and solar only. And then you got your batteries and your demand curve. So we're doing this. This is amazing. So all this extra power above demand needs to be going into batteries, right? So we need to be charging batteries so that we can get more of the dark blue over here and fill up this gap. So any of the white gap that you see on any of these is filled in by alternative energy sources, mostly gas. So the more we can deploy the electric that uses during this period of time and turns off during the peak, the more we're gonna load shift into these periods of time that we need to. So energy storage in California by type. Right now we got 843 megawatts of commercial or residential battery, 540 of commercial battery, and then 5234 megawatts of utility scale batteries. We're getting there, man. But we're only a little ways towards our goal. We're only 13% there. So it's really, really important that we do this properly. So one of the reasons we love heat pump water heaters, and one of the reasons the state loves heat pump water heaters, is because these things are batteries. These things are designed to run when the power is cheap and then shut off when power gets expensive. And when you install one of these correctly and you program it correctly to the utility rate plan, you're gonna get a a run profile like this. 6 o'clock in the morning, the thing comes on, starts charging. You got up, took a couple showers in the morning, like my house does, and so the water heater comes back on to recover. It's recovering during the day. And when you program this water heater to the rate plan, it knows it has to have a tank full of piping hot water at 4 o'clock and be ready for the evening ramp to not run. So the way it does that is when you have this thing set at 120 or 130 and you get a nice piping hot tank of water sitting there waiting for you at 4 o'clock, it's just going to turn itself down real low, like to 100 or 110 degrees. So basically, it'll allow you to use the hot water out of that between 4 and 9. And if you use too much, it will come back on because it doesn't want to leave you without hot water. But most people don't use enough during that period of time if you've sized the system right for the unit to even ever run between 4 and 9 p.m. So this is a battery. We're using that power during the day when we have a lot of it, and we're turning it off during that evening ramp when we need to have battery power. So another thing is the utility company is going to have access to these. If you're putting these in with incentive programs, you're going to sign your customer up for time of use and also for demand response. And what demand response means is that if there's ever like a point where we used to get these alerts, like the orange alert, please don't use any electricity right now, turn everything in your house off and just sweat it out. These machines will be able to do that. They'll be able to deploy a signal to these and just turn the temperature down for a couple hours and then turn it back up. And so that's really important for the grid managers to be able to even things out. So these are going to be another tool for the grid managers to even things out. And if we install them right, your customer is never going to know that happened, right? Okay. So growth of it, we don't have the most current numbers, but in 2022, excuse me, in 2022, they were already delivering 141,000 units. Pretty crazy because just a few years ago, 2011, it was 23,000 in the whole country. Then it went up to 141 and it's climbed up even further than that now. So the switch is on. Anybody can be a heat pump water heater hero still. because there's a lot of people out there that are trying to talk customers out of it. And I talked to a customer yesterday. We were doing a virtual assessment with her, and she said that one of the plumbers that she came over that they called out, and these guys were going to try to be their general contractor and get a plumber, an electrician, and an HVAC guy. And we do everything in-house here, so they're going to just go with us so we can handle everything. But she was telling me that one of the guys said that heat pump water heaters weren't ready for prime time yet. And that they didn't like believe in them. So it's not the Easter Bunny, folks. Okay. So what's happening is as actual units being sold, which is pretty crazy, and then forecasting, right? So we're out here and we got heat pump water heaters are clicking up to where if it keeps on trend, they will outpace tankless water heaters in next year, 2026. Gas storage water heaters are on their way down. Even right now, they're selling less of them because they're selling more of these. And then electric storage water heaters are on their way down too. Now you can use an electric storage water heater to decarbonize a house and get rid of the emissions, but a traditional electric storage water heater is going to use 4 times more energy than a heat pump water heater if you install it right. Okay. These are no longer unicorns. These are no longer something that one person in the whole neighborhood has. And if we do a good job with these, the word of mouth is going to help spread them. But they're becoming the default and not the exception. So we need to get familiar with them and understand how they work so that we can be better stewards for the product. Okay. There's a lot of design considerations on these. So if you're thinking I'm just going to get one and I'll just buy whatever brand and slap it wherever, there's a lot of things we need to consider before we do this. So it's a tiny bit more complicated than just shoving another gas water heater in there. So what I know too is we've ran across this quite a few times, and I do plumbing classes about heat pump water heaters for plumbers for Southern California Edison. It's really it's a 6-hour class, so it goes into deep detail. But a lot of plumbers come in, they're like, well, I could just put a new gas model in 2.5 hours and be done with it and take my money and run. And I was having conversation with some of these guys in some of these classes, and they don't understand how the flue pipes work. And the flue pipes are a problem with a lot of water heaters, and you can see them as you go out there in the world and you see these burnt or these melted gaskets. I'll show you a couple pictures of that in a bit. But you can see those indications. And if you just put a new water heater in there without fixing that problem, it's going to do the very same thing. So what are we concerned with? Is it going to fit? Is it going to fit in the hole I need it to fit in? And is it going to be the right size for the customer? Right, for their family. What is the first hour rating going to be? How do I figure out what the first hour rating should be? And do I just go by code requirements or whatever? How many people are living in the house? Like if they've got a 2-bedroom house with 10 people living in it, maybe a 50 gallons not big enough, right? So we need to make adjustments around that. How am I going to get my electrical to the thing? Right? How do I explain to the customer that it makes a sound so they don't call me back later and say, hey, you never told me this thing was going to be loud. My family can't sleep at night. This is something that needs to be talked about before you put the unit in. Efficiency. The nameplate efficiency of these machines are based on laboratory conditions. If we're operating outside those laboratory conditions, it's not going to be as efficient as the nameplate says. So efficiency is going to have to depend on application. How am I going to do my exhaust? Am I going to put this in a small room and it's going to overcool the room and divert to its secondary heating elements? Or am I going to be able to exhaust the unit out and get the cold air out of the room? When there's a tankless on the outside of the house, how do I put one of these in and protect it from the elements? Like I've been asked 100 times, can this thing go outside? And no, you have to make accommodations for that. We need to worry about the filters. These things move air through them just like your refrigerator does. And by the way, nobody ever cleans the bottom of the refrigerator. I know I just looked at mine the other day and had to get in there and vacuum it out. It's only 2 years old and it had all kinds of stuff in it. But there's filters in these things that need to be cleaned. Do I have access for the customer to get in there and clean it, or do I need to come out and put them on a maintenance plan? Do they have an existing or new recirculation pump, or do they have an existing continuous recirculation system? And what's that going to mean for a new recirculation pump? Because continuous recirculation with these machines is not a good idea. Um, all this, how is my existing distribution taken care of in the house? Where are the pipes coming in the wall? You got to look at that. How far is it from the router? Because it's got to hook up to Wi-Fi. What is the strength of the base of the system that you're of the potentially wooden base that you're putting it on in the house? I know there's some builders had like these wooden bases. It was basically the base was halfway up on the foundation sill, and there was a couple of 4x4 legs, some 2x6s, and a piece of plywood. It looks like they got all the stuff out of the scrap pile in front of the house to build a base. Is that going to be strong enough, or do I need to remove it? What climate zone are we in? Like, am I up in the mountains where it's going to be, sub freezing temperatures all winter? Maybe we need to make sure we design for that. How am I going to get the thing out to the house? They're heavy, right? This is not going to be something you're going to want to carry 3 of them on your truck because they're expensive and they're heavy. How am I going to route the condensate drain? We never had to worry about that with typical ones. You have with tankless, and then am I putting in a system that is eligible for the rebate? And am I telling them they're going to get a rebate on a system that might not be eligible? And then the JA13 compliance. The JA13 compliance is the communication protocol for the utility company to communicate with the unit. So all of these things are going to have to be considered. It's pretty easy, and I'm not trying to discourage you, but these things are important. Okay. All right. Luckily, we have more than one brand. And with these brands come alternative configurations. So I don't know if my microphone changed. So we have alternative configurations. We usually just we need one that's going to have top ventilation. We need a unit that's not the same one all the time, right? So if we're in a big space, we can use one with side ventilation. We need to understand if I got one with side ventilation, where's it going to hit on the wall? So there's a whole bunch of things that we need to consider, but there's a whole bunch of units out there for us to consider. Now, if a customer has brand loyalty, like they had a Navian instantaneous water heater in their house for years, and now they're thinking of getting a heat pump. Maybe they're true Navian fans. Maybe they just want that because of the brand. There's also units that are going to fit in smaller spaces. One of the issues with these units is as they get larger in gallons, and they have to be larger in gallons because they don't heat up quite as fast. They might be too big for a space another one came out of. So these couple brands down here are trying to take care of that problem. This ecological unit will be out on the market sometime this year, and this is a remote split system. So the noisemaker part goes outside, and we have a nice narrow tall tank, so we can even fit it into a mobile home closet or in a real small closet somewhere else in the house. And the beauty of this one is it's not going to make any noise inside the house. So lots of different options here that you need to consider. So what's the breakdown? How many SKUs does each company have, right? So Rheem definitely has the most SKUs. They have the most options for flexibility. They have a 40-gallon model, they have a 50-gallon model, they have a 65, and they have an 80. And they've got variable voltages in all of these lines. They've got dedicated circuit 120-volt units that plug into the wall, but they have to be on a dedicated circuit like a furnace, and that's got a much bigger compressor, so it heats up quicker. And then they've got the shared circuit 120-volt model where you just plug it into another outlet in the garage. And so they've got all these different options, 30 amp, 15 amp. So they're definitely the king of available options, but they are also one that can't be installed everywhere, right? So lot of units out there that are a lot of companies out there that are making new units. And if you think about, California is the largest market in the United States, right? And so all these brands, if they want to compete in this industry, they're going to have to come out with their own units. So hopefully they're learning from the mistakes of other manufacturers and not going to repeat some of them. But lots of options out there now. Okay. So what do we have really is 3 types. We have self-contained, where the heat pump is right on top of the unit. We have split systems. For a while, it was just really only the Sanco 2, but now there's multiple brands out there that are doing this. I heard there's another CO2 based brand coming out soon. can't remember which brand that was. That might be A.O. Smith. The is doing a split system model, but there's split systems, and then there's combi systems, combined split systems where you have one unit outside and it's heating water, and that hot water is being held in a large enough tank that it can actually heat the house with that hydronic with a hydronic coil and that hot water as well. So lots of options as far as that. We have 120 volt units, and don't be afraid of these. Now, the only heat pumps I've ever had in my house have been 120 volt plug-ins. And I did that because I wanted to get the water heater put in, and I had an outlet right next to where I was going, and I was too lazy to run the wire. And at the time I didn't have my span panel in, so I was kind of tilting at the edge of capacity at the time. But I put the plug-in water heater in. I only had one remarkable time when it didn't provide enough hot water, and we learned from that. Like we never did that same scenario where we did tons of laundry in the morning, coming back from vacation, washed the bedding and everything when my wife like washed everything, washed all our clothes, and then on the third shower my wife ran out of hot water. So now if it was me that ran out of hot water, I probably would have forgotten about it by now, but I still hear about it once in a while. So the pros is that this is going to avoid some electrical expense, right? So generally running a 30 amp wire to one of these units, we charge 1274 for that for up to 30 feet of wire. And we can save that and not charge them that if we can put a 120 volt combi unit in and just plug it in. And then when we're electrifying everything in a house, it also allows us, if we use a shared circuit model, we don't have to declare the power of this in our load calculation. Where if we put a 30 amp one in, we have to put that into the load calculation. That could push us over the top and potentially require a upgraded panel or a switching mechanism of some sort. The cons to these is they are going to run longer because they're only heat pumps. So there's the only thing in here is the mechanical unit heating the water. So most heat pump water heaters that are not 120 volt have secondary heating elements built into them. One of the other brands that has 120 volt model has a secondary heating element put in there too, but it's so small, it might be able to keep the water warm, but it's not going to be able to heat it up. But that gives you a larger first hour rating, but it throws off the performance of the system enough that it doesn't qualify for rebates. If you're going to put one of these things in, you need to look at the chart and make sure you're putting in the right size for the right house. Otherwise, it's not going to be up to code. So you can't just, like, I have a 4-bedroom, 2-bath house. You're supposed to put in an 80 gallon for that house. They're going to be a little bit more sound involved, right? We don't talk about noise until our customers trigger on sound. So there is going to be more sound because it only has the compressor to reheat the system. So all the water you use and all the cold water that goes back in has to be heated by that compressor, and there's no secondary elements, so it's going to run longer. So there's more sound. They don't work as well in weather below 40, but mine works fine. My garage has gotten down to 45 degrees when the unit's running, and it works fine. So it does have longer recovery. The time that in the 65 gallon one that I put in my house, we burned through all the water and used enough of the water out of the tank that the tank couldn't recover fast enough to keep up with our demand. Like I said, that only ever happened once. The But because of that first hour rating and that longer recovery time, and it was in the middle of winter, so it took 6.5 hours for that 120 volt 65 gallon unit to recover. But we had all our laundry done for the day. We weren't home for dinner yet, so we weren't going to use the dishwasher, and everybody took their shower. So I didn't need water during that period of time, but it did have to run all day to recover. Okay. We got these cool split configuration units. Now we install tons and tons of these things. This is called the Sandco 2. If you guys have never seen one of these, I'll explain it a little bit. This is an outdoor unit where kind of the noisemaker is. These units are inverter technology. If you're not familiar with what that means, it means that the compressor can speed up and slow down. It's not just a fixed speed compressor like the self-contained, most of the self-contained models are. So this unit right here heats the water internally to the unit, and you only connect up water pipes to it. So it's got its own little pump in it. This unit is designed to heat water up to 147 degrees at a little under 2 gallons a minute. And it'll do that with 55-degree water, or it'll do it with 90-degree water. But when it has return water that coming from the tank that's kind of warm and it's just reheating it, it's just going to use a lot less energy to do it because it's only trying to get that whatever temperature water that is, it only has to get it to the maximum output temperature. So it runs really fast and really hard when the water's really cold, and when the water is coming back, it uses less energy. So it does recover quite quickly compared to some of the other units. 115 gallon um, an hour in, I don't think that's 115 gallons an hour. 145-degree temperature, 83-gallon system. It's got a heat recovery of 115. So this also uses CO2 as the refrigerant. So if this everything ever has a refrigerant leak, it's like taking a jog and breathing hard outside. It's not going to hurt the world, right? These are also 15 amp breaker. They're also, the tanks can be put outside with no protection. The only thing that's going to connect from this unit to this unit is a small sensor wire and the hot and cold water lines, right? So works really, really well at super low temperatures because it's got that CO2 refrigerant. That CO2 refrigerant is a very high pressure refrigerant. It carries a lot of heat. The disadvantages, but if you're a company owner, this one's not a disadvantage. The disadvantage to the customer is if they need one of these, it's going to cost a little bit more than a typical one. But these are very application oriented, right? So only people that are going to need these are going to need them. So they know I want a heat pump water heater. The other one won't work here. So I'm going to have to pay more for this solution. But for you, not a disadvantage. You're going to make more money. Additional time required. We've got these down to where they don't take much more time than a standard water heater now because everything's super easy hookup. Once you've got the electrical to the outside, we're just running pipes from here to the incoming side of the tank, to the leaving side of the cold, comes back into the cold side. Hot goes into the delivery side of the hot. You can do it with PEX. They recommend PEX. So it's really a quick install. However, the first couple are gonna, there's like you got to put in valves and stuff that you wouldn't be used to. But after you've got a couple of these things under your belt, it's not a big deal. We can also cascade with these. So this is a job we did in Oakland where it's a Victorian house and a separate family lives upstairs and a separate family lives downstairs. It's two apartments they built in one house. But they still have one electrical service that they share the bill. And so we had one unit outside heating two 83-gallon tanks of water. And now neither one of these customers are ever in under any circumstances going to run out of hot water. And we've got one unit outside. And this one is I think this was like a 28 or $29,000 water heating system. So you can see the mixing valves in there. There's a mixing valve over here. The other one I think is over here. But they're set up separately, but using one Sanco to heat them up. So pretty cool. So what are some of the considerations that you need to think about when you're doing this? So let's talk about that for a minute. One is if you're going to put a self-contained water heater in in a space, we have to be concerned with how much air we have around it. So it's really better, it's ideal if you have this in a big garage and you have 1,000 cubic feet of garage space, you don't have to worry about anything. This unit is going to perform a lot of times better than the UEF or the uniform energy factor, and a lot of times maybe not as much, but it will have enough air to circulate that we can take full advantage of the heat pump portion, which uses about 1/10 the amount of power as the heating elements, right? We want the heat pump to do most of the work and the heating elements to just pick up the slack if we need to recover the water more quickly. So we do have to keep into consideration that we need to manage the cold exhaust to moisture issues. There has been cases with some of these units where they have a side discharge and the side discharge was blowing up against a wall, gets that wall really cool. Outside is 70 degrees. There's like 50% humidity. There's going to be condensation on the inside of that wall. So we need to make sure that the air is moving into the open space and not like refrigerating a part of the wall that's going to create a condensation problem. We need to raise the exhaust air above the dew point by mixing air or ducting it to a safe location. And what I mean mixing air, put it into the middle of the room, blow the air into the middle of the room and circulate it into the middle of the room. Don't blow it against the wall. Or if you have to, you can duct the cold air out of the garage if you need to. But if you got 1,000 cubic feet, you don't really need to worry about that much. When you put one of these in a closet, though, a closet's not 1,000 cubic feet. A closet's usually 2.5 feet by 2.5 feet. We obviously can't put one of these in there and not like vent it out because it'll get the closet so cold that the air will be so cold in the closet that it can't pull any more heat out of it. And then it's going to revert to its secondary heating elements. And when that happens, our efficiency goes right out the window. So follow the manufacturer specs at minimum, but keep an eye out for unique instances and the dew point of the air. Mostly in California, but there has been some cases in California that they've noted on some of these research studies. But mostly in California, our humidity is pretty manageable. This is going to be a much bigger problem in the Midwest and the Southeast and even the Northeast, where we have a lot of humidity in the air during the summer. Okay. So position the exhaust away from surfaces. We mentioned that, and ensure sufficient airflow, minimum of 40 cubic feet per minute per 100 watts of compressor power. So most of these units move about 125 cubic feet per minute of air with the fan systems that are on them. So that gives you an idea of what that is. Okay. All right. So here's the room size. They did a lot of research on this, and this is how we know like where these cutoff points are. So this is a graph that shows you why the energy profile changes when you install them in smaller spaces. And really, this is what the manufacturers are going to tell you: 700 cubic feet minimum. If you got 1,000, you don't have to worry about anything. 700, it's going to start choking off a little bit. And there's a possibility that we could cool that space a lot or too cool in the wintertime and not have warm enough air for the unit to pull heat out of, which just means it's got to run longer, right? So we have right here like the 700 cubic foot cutoff point. And as soon as we get down here like 450, one of the brands says 450, but they're willing to go with this. I'm not. I want my system to perform at maximum capacity and maximum efficiency all the time. So we see this dropping off. So our COP is getting lower and lower. If you don't know what COP is coefficient of performance. That's the amount of work we're doing for the amount of energy we're using. In other words, how much heat I can move for 1 unit of energy. So at 1,000 cubic feet, these things are doing like 3.5 units of heat, up here, 3.5 units of heat in an open room for every 1 unit of electricity. Gets a little bit lower depending on what the draw patterns are, but um, so as we see here, we get down to what is this 500? We really start diving a lot, and so if you've ever seen a heat pump water heater that has a side or back discharge put into a closet, and there's not a lot of good ventilation in that closet, you will see that it's going to use more energy than it needs to. If we're going to sell our customers and we're going to show them on the brochure, look at this, what the rating is here, we're going to tell them the COP story, we better put it in a way that it's going to provide that. Because if you put one in and it costs that customer $1,000 a year to run the thing, they're not going to be happy and you're going to end up pulling it out or putting one in and reventing it or something. But look at down here, when we get to an average size closet, how low we are. Like we're not much better at this point on this draw pattern, 84-gallon draw profile. We're not better than a regular water heater. A standard electric water heater is right here at 1, right? It's 100% efficient. You're getting 1 unit of heat is giving you 1 unit of energy is giving you 1 unit of heat converted to BTUs. So we need to be up here to provide our customers the system that they paid for. When they operate down here, it's not good, and it just means we sacrificed on our installation design, and we saddled this customer with something that's going to cost a lot of money. It already costs them a lot of money to buy it. They think they're going to save energy, and we're going to put one in that's going to hobble their efficiency. We don't want to do that. Here's kind of why it does it, right? 1,000, we got these great COPs, like 1 unit of electricity, 3 units of heat. I got 300% efficiency. We're all good. Starts dropping off a little at 700. But then you see when it gets smaller and smaller over here, And then we're getting into these dark lines. And what these dark lines are is the heater elements kicking in. So the heater elements kicking in throws everything off. We want to design these so that heater elements only need to be involved if there's a higher demand on the water, not because we created a higher or a lower efficiency installation spot. Here's some information from one of the major brands here, and they're talking about their minimum square feet. They're okay with the 450 on this one. My thing is 700. You should have 700 minimum. 1,000 would be best. But they're saying we'll spec it at 450. We're okay with whatever the performance is at 450. But anything below that is going to start dropping like a rock. So when you have a low number like this, we tend to say, oh, it's 450-ish, it's kind of like 430, or it looks like maybe about 300. That's close enough to 450. That's why I like high numbers, is because even if we err to default against those higher numbers, we're still in the safe space, right? So if you're putting this into a closet with a closet door, and you take your tape measure in there and you're measuring it all out, you get your calculator out and you go, great, I got 450 cubic feet in this room. And then you slide a water heater in there. You no longer have 450 cubic feet in the room. You now have all the space that's left around the water heater. That water heater takes up some of those cubic feet, right? So you got to consider that as well. They say if you have a fully louvered door, you can have 84 cubic feet of space. I would never do that personally, and then upper and lowers, you can do 84 cubic feet. Upper louver and undercut door, if you just, like the undercuts, I don't know, in everywhere I work, like, I don't want to undercut an outside door because it becomes a pathway for varmints. But if we do just one thing on this, we can get it to 0. And I'm cool with this. Like, if we have a vented door, and we vent the cold air exhaust out of the closet, this can work fine. And you can have that thing touching on both sides and just barely fitting in there, as long as it's safe. And you can attach your straps and hook up your plumbing safely, get the disconnect in there. You can almost have no space, like 0 clearance, if you duct the cold air out and you bring the ambient air in one louver. Okay. You can do it in a solid room of whatever size as well, if you duct the intake and the exhaust into the system, and you're basically separating the circulation system to an outside source. So that's a good deal. But not all the water heaters out there are easy to connect ducts to. That's where this whole one brand in the hand comes in. If you're going in a tight space and you're using a unit that needs like big giant funnels put on it so we can attach a duct to it, or the duct comes out the side and it has to elbow up, that's going to mean I can't fit it in that small space anyway. So we need to have access to some systems that we can duct right off the top to make it easy. Okay. Here's one right here. Okay. So why would we want to duct it? This system here, I don't like putting these in the house if I can help it, but this one ended up being super quiet. I have a video from when we installed this with the customer, and we had the unit running, and she was really concerned about how loud it was going to be. And so we put foam board in the whole closet. We ducted it in. There's air intake from one of the old combustion vents that was from the old unit. And then, I don't think you can really see it, but the cold air is ducted into the attic space right back here. And so this thing's got a closed loop, and we did all this foam board. I brought the customer over to this, and I says, hey, I want to show you how much noise this makes. I was kind of like, it's probably more than, and then it was actually running, and we're just standing there, and I says, we're waiting for it to start. She says, are we waiting for it to start? And I says, no, it's been running the whole time. She goes, oh my God, you're so fun. But it sounded like a fish pump. Like, it was so freaking quiet, right? So, why duct? But there's a couple of reasons. Like, space constraints is the most important reason. You can get an efficiency boost in some cases if you're pulling air from another area, like outside, but might not be great if you're pulling air from outside and it's 30 degrees outside. So you might get an efficiency boost in some cases. Relocating the exhaust if cool air in the room is an issue. Like if we did one in a basement over in San Anselmo last year, and the customer was really concerned. He says having the cool air down here in the summer isn't a big deal, but when he's working in his basement workshop, he would rather not, have a refrigerator running down there in the winter time. So we ended up running the air to the outside, and we put like a Y branch on there so he could whatever. I don't like doing that, but he was that guy. Okay. So clearance can be tough, especially with certain brands. We want to make sure now most of the heat pump manufacturers are getting the clue. For a long time, there was most of these brands you had to connect the cold water to the bottom of the tank on the side and the hot water to the top of the tank on the side, and that made for all of this extra plumbing to go everywhere. The industry's gotten kind of beyond that. So if you're thinking about just getting into installing these, you've got a better selection and sourcing of equipment that we had 6 years ago when I first started installing these things. One of the biggest reasons that I was installing heat pump water heaters early on was combustion issues, because we were going in, I told you I'm a BPI guy. We were going in and tightening up the building envelope, putting some good insulation in, tightening up the ductwork, making sure it's all good. And then we do a worst case depressurization test, and the water heater flues would fail all the time. So we ended up just like, this is the only solution I have for you so that your water heater flue situation isn't going to fail once in a while. And we don't want a water heater flue failing, because that means the exhaust is coming right in the house. Okay. Do not restrict the diameter if you must follow the manufacturer requirements. In other words, these are 8-inch duct takeoffs on the top of this thing. Don't get an 8.4 reducer and just blow it out the flue. Okay, don't do that. Keep it straight. Use mechanical transitions to come off here. Like these, mostly this has an elbow on it and it goes to flex pipe, but it doesn't have to be mechanical everywhere. Understand that you must insulate the cold air exhaust on this thing. And the way we do that when we're ducting it out is we take the old flue hole in the ceiling and we open it up to 8 inches, and we put a piece of metal collar in there and a piece of metal duct above it. But you have to insulate that metal duct above it, because when that cold air goes through that pipe that's sitting in that hot attic, it's going to condense, and then it's going to create moisture. So be careful about that. The terminations must not let water in, and be mindful of pulling super hot or dusty intake air. Don't ever think you're going to boost the performance by pulling hot air into the machine from the attic space, because one, it's dirty, it's gonna get the filter plugged up more quickly, and two, these units won't run if the intake air is over 119 degrees. They just shut down and they revert to the secondary heating elements. So we never want to take hot air out of the attic. We're okay blowing cold air up into the attic. Okay. All right. So ducting continued. Some of the brands you can duct, I mean, you can duct all of these if you want to buy the extra kit for them. Now, the extra kit for one of the brands we used to install, they sold this kit for like $350, and it was probably $2 worth of plastic and an injection molding machine. And the manufacturer was like, "You don't need this. It's fine. Just put it anywhere. It'll work." And I said, "Yeah, it'll work, but it's not going to work at its peak efficiency." So this particular brand did something kind of cool. They changed the stamp pattern on the exit vent and made it so you can fold up these tabs, and you can you can kind of cut a little concave into an elbow or a piece of KD pipe, and connect a duct directly to it, which is a little better. Their previous version of it actually had a duct connection on the top and the side, which was a little better. But if you can imagine putting this into a closet where there's no space, and not having the luxury of going out the side like this, and then you got to put one of these big old funnel things on here. It's this particular one for this unit. One of these big old funnels on here. I know it's this one for this unit. That funnel sticks out about 8 or 9 inches, and then I got to bring a duct off of that, potentially an elbow to go up. That's 18 inches of space I don't have. So if you're going to get one that's ducted and you need to put it in an application where it's ducted, get one with the top duct connections on it. Okay. If you're going out and looking at one of these and you're going to sell it, you say, "Hey man, I'm going to go get my first heat pump water heater job today. I got all the information I need. I'm feeling confident. I got this going." And then you get out there and you don't measure the door frame. You go, "Yeah, this should be pretty good." And you don't know your product well enough. And you say, "Well, this house, I got to up this thing to an 80." And you don't realize that an 80 is 23 and a half inches or 24 inches in diameter. And you have 20, you have a 28-inch door frame and you have a 28-inch water heater. It doesn't matter how much zoom oil and how much muscle you get trying to push this thing. You're not going to get a 28-inch water heater in a 24-inch hole. So if you find this while you're at the job site, you can charge for it. If you don't measure this and the guys get out there and it won't fit, guess who's paying for it? It's not going to be the homeowner because they're going to go, "Dude, you didn't measure, right?" It's going to make you, put a little egg on your face. So notice all the space, note all the space dimensions. Make sure you've got a place in the back to put that disconnect switch. Remember, these are always, it says usually bigger than an existing gas unit. These are always going to be bigger than a gas unit in most applications because we have to upsize it from whatever the gas water heater is because of the recovery time. You need space for a mixing valve on these. So you got to put a mixing valve on the top. Some of these units have a filter that comes out of the top. I'll talk about that more in a minute, but you need space for the mixing valve. So if you've got a unit that's a little bit taller, you have to put a mixing valve on top of it. And you had a shorter water heater in here and the takeoffs are coming off the connection points are coming off the wall and it's too short. You got to know that before you get in there, right? You got to know that, like, I'm going to have to open up this wall a little bit, extend these up and come out high enough that I can go into my mixing valve. Notice the path of electrical. When you're looking at this, just see where's my breaker box. Do I have space in the panel? That's a whole nother class. Where's my breaker box? How am I going to get a wire from point A to point B? Might be one of those things where you want to call the electrician. You guys might be fully into doing electrical work too. It is important to note that you as plumbers can run the electrical to this if it's in the scope of your water heater. You just can't do any other electrical work, right? Most units are 240 volt, 30 amps. There are some units that are 15 amp, but it's a special order unit from one brand and that brand doesn't fit everywhere. If you got an existing 120 volt outlet nearby, maybe, do a 120 volt plug-in, just size it correctly, make sure it's going to qualify for the incentives. And that might be a better plan if the electrical panel's full or it's going to be really hard to get a wire over there. I love the ones that are in garages and the electrical panel is right on the outside of the garage. That's such a walk in the park. Okay. So here's a little fitment, little check-in on fitment. So heat pump water sizes vary different are very different from gas tanks they're replacing. They're going to be wider and some of them are going to be taller. You got to check the T and P and the condensate heights on these things. Condensate usually isn't an issue because we're installing the condensate situation at the time we're installing this, so we have a little bit more leeway. But if you've got the TP valve exiting pipe inside the drywall and say, what is here? The TP valve, the floor to the TP on this unit, the TP valve is 38 inches from the floor. Now, if I had an old 50-gallon water heater in there that was 50 inches and they piped the TP valve right off the top and into the drywall and out, that means I'm going to have to open up that drywall and bring out that TP valve lower so it'll fit. And I got to do that before I shove the thing in the closet, right? Also, if you're going into a house that has a basement space, and we're putting this in a basement and the foundation is higher than the TP valve, you have to make a concession for that. Maybe you have to raise it up on an AC pad just to do it a little bit. Maybe you have to build a little stand for it, but then we got to think about the amount of room we have at the top, right? So the TP valve can be something that can be a real time suck if we have to do that. We had one where it went into like this basement pit and the foundation was like at 60 inches. So we had to come all the way around. We had to follow the foundation all the way around, like, I don't know, it was maybe 5 feet this way, 10 feet behind the HVAC system, all the way down, came 10 feet down that wall, had to turn another 5 feet, and then it had to go outside the little basement door. So we actually had to put it down there and had to cut a little notch next to the basement door because there was no way we could go through the foundation. And it was fine. It worked out, but it added like multiple hours to the project. So top or side plumbing based on height and width restrictions. So some of these units, most of them now that are coming with top connections are coming with secondary connections on the side as well. So they have optional side connections, optional top connections. If you're going and replacing a heat pump water heater that's maybe 10 years old and it had side connections, you can still get one where you can slide it in there and just reconnect it on the side. But if you're replacing a gas water heater and everything's coming from the top, you really want top connections so you don't got to plumb all that crap on the side, right? So these are all 50-gallon models. So the 65s and 80s might be a little bit different, but so these things are like 60 inches tall. This beast here, this Ream Pro PH50 is 64 and 3/8 tall. This one right here, the new GE GeoSpring unit that's coming out, is really cool unit because it's 120 or 240 volt in the unit. But that thing's almost 70 inches tall. It's like this tall, right? So that's going to give us the most height on the TP valve, which is a good thing. But we got to worry about like, am I going to have to put this down into a basement and can I flip it up and not, not hit the basement with 68 inches tall? That's going to be something we're really going to have to consider. Okay. All right. So noise prevention. Be mindful of putting one of these in a hallway closet where near the bedrooms. There's a lot of houses that are like that. When you walk down the hall, the furnace is in a closet and the water heater's in a closet, and it's gas, and those are terrible houses because there's such a high opportunity for exhaust to get into the house in those applications that it's just a terrible place. They never should have put gas appliances in like that. Um, but talk to your customer about that. Let them know this unit is going to create a sound you are not used to. How quiet is your lifestyle? If they've got a bunch of kids running around the house and they always got the stereo on or the TV on, they may never notice it. But if they're the type that sits down and just like reads all day in a chair somewhere, that little sound in the background could drive them completely insane. And that works out to driving you completely insane because they're going to be calling you every 20 minutes, right? So if they trigger on the idea of a little new sound, then we need to talk to them. They're going to say, well, what's it sound like? And it really sounds like a heat pump water heater, right? It's a kind of a combination between an air sound and a buzzing noise. It's a little bit like a dishwasher, kind of like a dryer, sort of like a refrigerator. I mean, it's a bit of a unique sound. The thing is, it's a new sound they're not used to, and so we need to make sure they're prepped and ready for that. Which you also have like that Sandco unit in your back pocket. Like if they trigger on sound and say, I don't know about that, say, well, I've got this other solution for you. The machine that makes the sound is going to be outside. I'm just going to put in a tank and you're in here and it's going to be dead quiet and it's going to be amazing. And by the way, it's only twice as expensive, but you really want to heat pump water heater. And then you're going to go, cool, I sold a Sandco because of sound. Now you might think that customers will not want to spend $16,000 on a new water heater, but I will share with you that they do. Okay. Use the install tips. Flexible pipe connectors. If you got one that you've got rigid all the way down with the old water heater and it used the unions and it piped right into the top of the water heater, you need to bring back to the turn, put your ball valves up there and go flexible. We don't want these things now have a machine in them that's vibrating. It's not a lot of sound, but it could resonate through those pipes. So you want to be careful about that. When you attach one of these units, the only time we've seen this be a problem is they can pass vibration into the house. I've ever only seen it a couple of times, but the only time it's ever popped up is when we strapped it to the outside wall and an inside wall. Like it's in the corner of the garage, and we put one side of the strap on this wall, and we put the other strap to the other wall. That has been a problem. So you always want to strap it to the same wall, whether you strap it to the outside wall or the inside wall, but just strap it to the same wall. It creates some kind of weird imbalance vibration thing. So you're going to want to put a foam pad underneath it. You're putting it on concrete. You want to put a square of foam underneath the pan so it doesn't transfer heat down through the bottom. And that's also going to absorb some of the vibration or some of the noise. Put a little rubber grommets behind your earthquake straps when you put the lag bolts into the wall. That helps as well. Um, acoustic panels. I will never install one of these inside a building envelope like this because it's kind of outside the building envelope, but inside the house where it's accessible from inside the house without fully insulating that with foam board. I just won't do it because it's really hard to get this foam board in after that unit's installed, right? Okay, pick a quiet unit. Most of these units publish their decibel levels, but they're not going to be consistent. Once again, laboratory conditions. All of these systems are tested under the same laboratory conditions. When it's running in situations that's outside laboratory conditions, like the water's coming in real cold and it's got a real cold environment, it's going to open up the expansion device a little more, and the compressor is going to have a little bit of a different sound. So we need to tell the customers when we install this it's very quiet now because it's heating up and it's doing its job, but there might be an occasion where it's a little bit louder or a little bit quieter. That's perfectly normal. You don't need to call me. Please don't call me. Don't call me unless you don't have hot water. Two units may have the same decibel range but different frequencies. I've had this brand in my house in the 120 volt is what I have now, and I had another brand in there before that was 120 volts. That the other brand had the fan right here, and it's right next to my garage wall. So you got to kind of turn it so the fan doesn't, so the air doesn't hit the garage wall. But that one was very white noise centric. So uh, it's just you got to be careful about that. So if they're super sensitive, just use a split unit. Okay, they're heavy. You're going to need a good lifting device for these. 300 pounds, these 80-gallon models weigh 300 pounds. And if you do the math quick in your head, you put 80 gallons of water in there, these are like 1,000 pounds, a half a ton. Make sure you got a good lift out there in your world. Watch out for the strength of the existing structure and platform. Make sure the dimensions are proper. Think twice about putting one of these in an attic, right? If I'm putting one in an attic, I'm only going to want to put a 50-gallon up there. You're going to haul these things up and down the stairs. We have one of these dollies that kind of carries it up the stairs, right? We have this dolly that's a stair climber dolly, and this will also lift it up high places. So have some good stuff. Make sure you put the earthquake strapping on properly. Make sure you have the right gauge of metal, and then make sure it's going in the right place. So you're going to need, we use 120-gallon straps, and we only have to do two. If we use the thinner straps, some of the inspectors want three of them. Okay. Remember, there's a filter. Leave room for the filter. So this one's got the filter that's flat right here, but still incredibly difficult to get it out there. This one is like this is in that unit that has the most skews. This thing's like a, 18-inch square. So I need to be able to pull this out. If I put this in a basement and I can't pull the filter out, that's going to be a huge problem. Or if my guys don't understand there's a filter in there, before you send your guys out to install one of these, do a quick triage on it. Look at it, make sure like, hey, you got to make sure the pipes are going to let this filter out. Oh, wow, there's a filter. Okay. Right. Because if you can't get this filter out, you're going to have to come back and replumb the thing in order to make the filter accessible later. So I've seen this a bunch of times. Okay. Be mindful of space heat interactions. If you're going to put one of these inside the house or in various areas of the house, there can be interactions. If you're putting cold air in the house, like if the thing's sitting in the closet or it's in a laundry room or whatever, and it's putting cold air in the house, whatever your heating source in the house is going to have to compensate for that. So they did a study on this, and they found this is in Florida, which is kind of cool. And they were looking at indoor installs, garage, basement, outdoor closets are okay. You don't have to worry about it that much. But you can expect a 2 to 5 degree drop in space temperature following a cycle. Biggest issues come when the unit blows cold air on the back of a thermostat or an adjacent wall when a thermostat's behind it, or it's putting the cold air into the house and the heat has to offset that. Avoid crossing the pressure boundary when you're venting. Never vent. If it's inside the house, never vent one side, vent both. Okay. What it did on this one is indoor to indoor, saved them 3.8% on the cooling, but look down here. Indoor to indoor cost them 6% on the heating side. If you're taking air from outdoors and exhausting it indoors, that was costing almost 20% more to heat the house in the wintertime when you're doing that. So just be mindful of that. Uniform energy factor. Okay, this is the lab conditions that everybody bases all their efficiencies on. It's 68 degrees, 67.5, 68 degrees with 50% relative humidity with a water temperature, a first water temperature of 58 degrees. So there are going to be some times when this machine out in the real world is operating under lab conditions, right? There will be this point in time where the relative humidity is 50 and it's running at 68 degrees and we're putting 58-degree water in. But that's going to be one small moment in time, right? If we're operating in an area where the incoming air is, say, 80 degrees and the water temperature is 70 degrees, that's going to make the thing a lot more efficient. If I've got water coming in that's 45 degrees and I've got lower humidity and a lower number here, that's going to mean use more energy. So sometimes these are going to perform better than lab conditions, and sometimes they're not going to perform as well as lab conditions. But consider that's what all of these are based on. They tested in different modes to reflect typical patterns. And what they're measuring is how much energy is going into the system and how much water, how much heat am I delivering for it. And that's where that COP comes in. Okay. All right. First hour rating, it changes on every unit. There are required first hour ratings depending on what size house you're putting these into. If you've got a 2-bath house with 5 bedrooms, you need a larger water heater than if you have a 2-bath house with 4 bedrooms, because obviously there's the opportunity for more people to live there, right? So you got to look and see what that first hour rating is and match it for that, because if you don't and you get a really savvy inspector and he comes out and he goes, hey, this is a 3-bedroom house or 4-bedroom house with 2.5 baths, I want to make sure this thing has that right rating. You might end up pulling that system out and putting a different one in. So just consult that first. Okay. Know your products. When you start doing these products, read the literature on them, get to know them. If you're selling one, if you're a sales guy, or if you're not the installer, when it gets to the shop, uncrate the thing. Look at everything on it. Just kind of familiarize yourself with everything. Bring the installer in before he goes out to the house with it and go, look, what's the strategy around this? This is what we need to do. We need to make sure there's room for this filter. We need to do all this, right? That's going to save you a ton of time later. Believe me, we got burned on that so many times. Okay. So here's some application scenarios. We have this thing called the application game. Um, so if you ever come to one of our live trainings, we have this game that we do, and it's basically all of these locations, what is the right solution for it? So we got a unit outside replacing a tankless. What do I need to do that? What system will work for that? I got a unit in the garage. Just about anything, right? I got one in the laundry room. I got one in a small closet, or I got one inside the house in a closet. So let's go. Let's check it out. Okay. So if you got a standalone outdoor system, okay, you have 2 options. You can put in a split system that is approved for outdoor locations, which is like that Sandco unit and a Sandco tank. Or if you want to put in a traditional or a typical tank top version, you're going to have to build an enclosure around that. These are not rated to be outside. So you could do either, but one doesn't take an enclosure and one does. You might want to put the Sandco in there, run the outdoor unit somewhere else, put the tank outside where the old tankless was, and then build a little enclosure over that. You might want to do that. But if you're going to have it out there, it's going to be in elements. It has to be outdoor approved. And if you're going to use a regular one, you have to build an enclosure of some kind for it. And if you're building an enclosure for it and you build one of those metal ones, you need to insulate the inside of the enclosure and you need to vent the cold air out of it. Otherwise, it's gonna sweat like a Budweiser can. I don't know. I said Budweiser. I don't even drink that. Coors Light. Okay. Build insulated and vented enclosure, duct out the cool air, and filter the incoming air when possible. If you're going to build an enclosure and you're going to have incoming air, just put a grill on there where you can attach a filter to the backside of it. So you pre-filter the air that's going into the closet. It'll make the filter on the water heater. If the customer forgets to clean the filter on the water heater and you put like a good filter on the wall, it'll go for a long time and not be a problem. Okay. And don't forget UV rated pipe insulation and fittings if you're going to have it outside. Okay. So we got a standalone outdoor. This is that scenario right there. Took the tankless off, had to build this enclosure. This is what the inside of the enclosure looked like before we cut in the vents and put in the water heater. But all wood enclosure, all foamed out with foam board in it. So I'm not going to get any kind of sweat on the inside of the cabinet. And then I'm venting it out both sides. And look how cool that matched the trim and everything. Obviously, they hadn't painted it yet. We weren't going for a Brady Bunch bus look. Okay, so here's another one. Outside location. Really wanted a heat pump water heater. Um, Put this one in, and it looks for this is a little bit misleading. This does have a tilt on this roof, as you can see by the dimension of this, because it looks like it's kind of flat. It's not flat. This one has the intake vent here, and it has the exhaust vent going out the other side. And so it's pulling air from outside through the closet and then exhausting the cold air outside. But really the only solution for these, we have a couple of cities in our area, and you guys probably do down there too, because you have small houses and people have gotten the tank out of the house where they put a tankless on the outside of the house. You're like, what the hell we do now? So you can build a nice enclosure like this. You could build a sheet metal, you can get a sheet metal enclosure from Home Depot and insulate that and use that too, but you do have to ventilate it out. And most of my customers don't want that on the outside of the house, although some have. Or you can do this, right? You can put the whole unit outside. Okay. All right, so garages. Now, garages are really forgiving. If it's enough space, you don't have a problem with it. There are some units that have the fan coming out the back. You don't want to push that up against a wall. You want to consider that. But almost any heat pump water heater will work in the garage if I've got at least 700 cubic feet of space, at least, and or to 1,000 would be great. But they might come and park two minivans in that at at night, and there's less space in there, so we've got to consider that as well. So avoid back or side exhaust that's going to hit the wall. If you have one of these that has side exhaust, don't put that directly up against the wall. You're gonna have to rotate it a little bit so the fan is blowing out away from the wall. Otherwise, you get that wall so cold that it can create condensation inside the wall. And never exhaust only duct in the house. Never take that cold, because you're going to have customers who are going to do this. You're going to tell them, hey, this thing puts out cold air. We need to exhaust it outside. And they're going to go, oh man, can you just bring that into my kitchen? I want some free air conditioning. And you're going to tell them, no, I can't pull air out through your garage and put it in your kitchen. I just can't do that. Right. The same reason why you can't have flexible ductwork in your garage. You just all the nastiness from your garage is just going to go right in your house. Okay, so don't do that. Okay, couple options here. So this one has top intake and discharge. This one has a flat filter that pulls out of the front, so the mixing valve is not an issue. If this particular mixing valve was on that other brand that has the filter that pulls out, that filter would go tunk, tunk, tunk. It'd hit that mixing valve, and you wouldn't be able to get the filter out to clean it. Okay, so it's almost like they knew, right? They knew we were going to have a bigger water heater on this platform at some point. Some of these you got to use a square pan too. So another example, this one was in a little closet in the garage. We ended up installing it outside the closet, and then the customer tore down the closet. So now it looks like it's kind of floating in midair. It's not, it's actually up against the wall and everything. It's just sitting here instead of here. So, but in the garage, side discharge fan. So it's not blowing directly up against the wall. It's going to be fine. Everything's going to be okay. You see our TP valve comes out and goes this way, kind of connected probably with the old TP valve. Can't really tell. Okay. This is what you'll run into sometimes. You'll have a narrow unit in a garage alcove, and obviously they're not going to let you just like tear the wall out and get all in their pantry and stuff. So you got to move it outside the thing. So it's going to have to be part of the garage now. This happens to be a 120-volt plug-in. You can see that. This is a telltale sign. This one has the built-in mixing valve right here. They call it the hydro boost valve. But you see we got the cold air pointed away, the control panel kind of pointed right there. Really, you got to stand next to the water softener to mess with the controls, but we could rotate the thing around a little bit, but we'd be blowing the cold air on the wall, so we don't do that. Okay. All right, so basements and crawl spaces. Oh man, this can be an issue. So ensure you fit through the doors. Double check the cubic feet of space. If it's height restricted, you don't want one where the filter is going to have to pull out of the top. You're going to have to use side or back discharge. but make sure it's not going up against a wall that the back discharge is going to hit the wall. Side plumbing versus top plumbing might be something you want to use on this because the unit's going to be bigger than the old one. So this in that application, you might want to redo the side plumbing. And you can consider a split hot water with or a low boy if it meets the FHR first hour rating. And that means there's the split heat pumps have a low tank. Their 43-gallon tank is only 38.5 inches tall. So man, you can stick those things anywhere. Got a lot of them under houses. So kind of like this, right? So we got it in there. It's all strapped up. It's all nice, and it's blowing the air away from any surfaces. So it's not gonna cool those surfaces and potentially um, create a cold spot on the wall. Okay. Here's another one that was kind of floating around down at the bottom. We put this unit in. Fortunately, we were able to go right outside the wall with the TP valve. We did choose to do the top connections. We used the ducted unit. However, we didn't duct it in this space. There was more than enough space in this area. Pretty cool little heat pump we installed here too. This is a normally a horizontal convertible vertical slim duct air handler. This is taking care of his whole bottom floor. Even got really good filtration on it, but um, got the tankless water heater over in the corner. I'm never going to get a tank water heater there. You don't have one that's short enough. It's not going to work. So don't end up doing this. Make sure you measure all the angles. Make sure you know how much that angle is going to be. If that unit is on this end and this end, how much room it's going to take to tilt up. Don't want to do that. So indoor closets, we need to be mindful of the sound. We need to put a ducted system in there. We need to vent both sides. So you need a top vented unit if it's a small closet, and you're going to have to be mindful of the sound. You're going to have to put the insulation on the walls like this. This is that closet before and after. This looks like a Halloween prop, right? Like they'd be doing their trunk or treat on that thing. So this one, the inspector wanted the strap up high. These units also, some of them, they're way too busy to get the strap in certain places. Like there's one brand out there that's taken that into consideration. They've designed their system so that there's a perfect strapping space, but there's not a lot of room for that strap to go around here where it's not either going to interfere with you having to work on it later or go over some critical part. So be cautious about that as well. Okay, here's another one we did. This is the new heat pump here and the old furnace and everything here. And we did everything. We went in there, we got to seal up some gaps in the wall. We put foam board on all the walls, sealed everything up airtight, put it all in there. We just exhausted the duct out here, and we had a vent that we left in the floor for the intake air of this thing, that vent right there, because there was no way for us to put a duct down and pull the air from a certain space. I don't want to pull hot air from an attic space, so it left us with that. That was a good enough solution, but it is what it is. Here's a Sandco system that we could not put it in the house. The guy wanted to recover his thing, his closet. He talked to 4 contractors before we came out there. They all said, can't put a heat pump water heater in this house. I went out there. I didn't even go out there. We did it virtually. I says, we can just put one of these right under the house. It's not a problem. So he gave us a great review. It's like they were the only ones that came with the solution. Um, the but we put the outdoor unit there, put the little unit under the house, golden. Okay. Okay. So outdoor closets. Foam board is recommended. Ducting strategy is recommended. Be mindful of the sound if there's a sensitive area next to it. Triple check your dimensions. Avoid 120 volt units when they're going outside. Don't put a 120 volt unit in an outdoor enclosure, because if it gets below 34 degrees outside, that unit's going to shut off and it's not going to be able to heat. It'll have to shut off during that time when it's really cold, and it'll start up again when the temperature comes up enough. But be careful about that. Don't do that if you can avoid it. And top plumbing and top venting units tend to work well in those situations. Here's one right here. We had to kind of redo this cabinet a little bit. His contractor opened it up bigger for us. Now, his contractor did all this. Like you can see, this door is much smaller. We noticed the door was smaller and it wasn't going to fit while we were out there. So he paid his contractor to come rebuild the door. So we didn't have to deal with it. But if I'd have just sent a guy out there, sent my sales guy out there, doesn't know he's looking at, he sold one, you got out there. Now you're doing all this at your expense, right? So, okay. This is a kind of interesting one. They had the little closet in the garage, and we couldn't get anything that was going to fit in there. And so what we could do is we just open the side of this wall. He's actually got a door to the outside over here. We'll open the side to this wall. Then I can fit my 83-gallon tank in here, and we can just put the Sandco right inside the house, right inside here. As long as it's in a metal pan for the drain and it drains out to the outside, this is okay to do with these. And he gets a lot of cooling effect in his garage because this thing's 15,000 BTUs. So there you go. That's not a bad way to go either. Another scenario, in the attic, if you can avoid it, if you can, we put one in an attic so far. It's a 120-volt model. It's going to turn on when the attic is over, or it's going to turn off when the attic is more than 120 degrees. But that's okay because now I got 120-degree air surrounding the thing, right? So, all right. So that's the end of this one. Thank you for joining us. I hope you guys got something out of it. The come back to us on the 28th of next month for retaining profit. This has got some good stuff. Minimizing callbacks on heat pump projects. It's a big deal, right? There's the things you need to tell the customer, or your guys need to tell the customer to make sure the customer doesn't call you about nuisance stuff. Okay, Alex, we got 1 minute left. Is there a question?
I think the questions have been sufficiently answered in the chat.
Okay, very
Maybe
good.
we should save the last minute
Mm-hmm.
or so here for Juliana to close us out.
Juliana, we ran tight on this one.
Yes. Thank you so much, and electrify my home. Such engaging, informative content, and you all will get the recording and the slides coming to you soon. Please come back on August 28th for the Retaining Profit webinar. And one opportunity I'd like to highlight to this group is our Passive House Build boot camp with EMU Passive happening September 29th to Friday, October 3rd. It's part online, part hands-on training, and the exam. This is a $2,500 value that we're offering completely free. So more information is about that is on our website. And as always, you can see our calendar of events and trainings. So with that, I'll close this out. Thank you so much for coming. Please take the survey before you leave and let us know any feedback. And we really appreciate everyone's time this early Thursday morning. And thanks to Larry and Alex for your expertise as always.
All right.